Hi there, welcome to this Maths Tech 1 lecture on simultaneous quadratic equations. So you can see from the equation below that we've got a pair of equations, therefore they're simultaneous. But one of the equations is also written as a quadratic because we've got the x squared in it. So we're going to combine the last 2 weeks worth of work into solving a complex problem like this. So firstly, let us label the equations. Now we're going to eliminate the y's by using a method called substitution. This just means replacing one y with what the other y is equal to. So we can see from this first equation here that y is equal to 2x plus 2. And the second equation, y is also equal to x squared minus 1. So therefore that and that must be equal because the two y's are equal. So we can eliminate these y's by saying that x squared minus 1 must be equal to 2x plus 2. Because the two y's are equal, that means the other two things are equal. Okay, so that's helpful. Now, when we're solving a quadratic equation, it always needs to be of the form ax squared plus bx plus c equals 0. Now the 0 is the key bit. We can only solve it when it's equal to 0. And at the moment, the quadratic is not equal to 0. The quadratic, x squared minus 1, is equal to 2x plus 2. So what we need to do is we need to transpose using the knowledge from outcome 1 to make this equation equal to 0. So I'm going to bring each of these two things across to this side, and as they're both positive on the right hand side, they're both going to be subtracted on the left hand side. So we've got x squared minus 1 and then minus 2x minus 2, and now we've got 0 left on the right hand side. Now we just need to tidy that up a little. There's two like terms to collect. In this case we've got minus 1 and minus 2. So we're going to collect those. So minus 1 minus 2 is minus 3. Okay, now we've got a quadratic which looks like this. Ax squared plus bx plus c equals 0. So if you recall, to solve the quadratic, we need to use this formula, minus b plus or minus the square root of b squared minus 4ac, and then all over 2a. So we're going to solve that and find the values of x. Okay, so using that, we can see that a is equal to 1, because there's 1x squared. B is equal to negative 2, because there's minus 2x. And c is equal to minus 3, because that's a number by itself. So let's put these numbers in the quadratic formula. So at the start, we've got minus b, so it's negative of minus 2, plus or minus the square root of b squared, so minus 2 all squared, minus 4 times a times c, and then all over 2a. So let's start simplifying that. So minus of negative 2 is positive 2. And plus or minus the square root. So minus 2 squared is 4. And then minus 4 times 3 times minus, 4 times 1 times minus 3 is minus 12. 2. And then 4 minus negative 12. Those two minuses make a plus. So we've got 2 plus or minus the square root of 16 over 2. And then to find our two x answers, so we'll call the first one x1. That's going to be 2 plus the square root of 16 all over 2. Or x2 is equal to 2 minus the square root of 16 over 2. And from there, we get x1 is equal to 3, or x2 is equal to minus 1. That's our two answers for x. Now, that's all very good. We've solved for x. We found these two answers. But if you recall, the equation also had y in. So looking back up at the top, we've got y equals 2x plus 2 and y equals x squared minus 1. So again, this is where we come back to our simultaneous equations. We know that y equals 2x plus 2 and y equals x squared minus 1. Now you can choose one of these equations. Let's choose equation 1 to work out the y values. So there's also going to be two answers for y because we've got two answers for x. So if we let x equal 3, we can say that y is equal to 2 times 3 plus 2. So y1 is going to be 2 3s plus 2 is going to be 8. Okay. And similarly, if we let x equal minus 1, which was our second answer, y is going to be 2 times negative 1 plus 2, and that gives an answer of 0. We'll call that y2. So what we get is we get two pairs of answers. So our first answer was 3, 8, and our second answer was minus 1, 0. They're essentially pairs of coordinates. Okay, so that's what we're looking for when we're solving a simultaneous quadratic. We're looking for two pairs of answers. So let's do one more example. Solve this pair of equations using substitution. Now, this one's a tiny bit trickier because there's nothing we can substitute in yet. What we can say is we can use the trick that we used in simultaneous equations before, where we can scale equations up if necessary. So equation 1 has something to do with 2y, and equation 2 has something to do with y. So what I can do in equation 2 is I can double everything. So if I double everything, I get 2y is equal to 2x squared minus 18. Now the reason I've done that is because the 2y and the 2y are equal. So that means that whatever 2y is equal to, this 2x minus 18 can be substituted in for 2y in this first equation. Okay, and that eliminates the y's. So in equation 1, I'm going to replace the 2y with 2x squared minus 18 because the two y's are equivalent there. So instead of 2y, I get 2x squared minus 18. And then I get the plus x, because that was already there, equals 3. Okay, and now again, we're almost got a quadratic. We need to make it look like that, equal to 0. So the only thing stopping that is this 3. So I bring the 3 across, and I subtract it. So I get 2x squared minus 18 plus x minus 3 equals 0. And then I just need to tidy up by collecting any like terms. So I've got minus 18 and minus 3, which can combine. So I got 2x squared plus x minus 21 is equal to 0. Okay, again, we're solving for x. We're going to leave the y until the end. And because it's a quadratic now, we'll get two answers for x. So, quadratic equation, just recap that. So minus b plus or minus the square root of b squared minus 4ac all over 2a. So again, find out what those numbers are, a, b, and c. So a is equal to 2. B, remember if there's no number in front of the letter, it's 1. And C is minus 21. Okay, so let's put those numbers in the equation. So minus b, so it's going to be -1, plus or minus the square root of 1 squared, minus 4 times 2 times -21, all divided by 2a, so 2 times 2. Okay, so let's just tidy this up. So -1 plus or minus the square root of 1 squared is 1. 4 times 2 times -21 is -168. 4. And we get -1 plus or minus the square root 1 minus -168 is 169 all over 4. So we then find our two answers. X1 is going to be -1 plus the square root of 169 over 4. And X2 is going to be -1 subtract the square root of 169 all over 4. So your first answer is going to be 3. And your second answer is going to be -3.5. Okay, so that's our two answers for X. So we now need to find out our answers for Y. So let's recap what those equations were. 2y plus x equals 3, and y equals x squared minus 9. So equation 1, 2y plus x equals 3. Equation 2 was x squared minus 9. So it doesn't matter which one you choose. It's probably easier to choose the second one so you don't have to do any transposition. Okay, so I'm going to choose the second one. So letting x equal 3 as per the first answer for x. That means that y is going to be 3 squared minus 3. So y is equal to 0. So call that y1. And then letting x equal minus 3.5. Y, subbing that into the equation number 2, is going to be minus 3.5 squared minus 9. So y2 is going to be 3.25. So again, you get two pairs of answers. So your first pair of answers is 3 naught, and your second pair of answers is minus 3.5, 3.25. Okay. So this is obviously quite tricky, so please take your time with it. Go back over the video if you need to at any point. And the work that I would like you to now do is go into Moodle, click on Simultaneous Quadratic Equations here, and it comes up with the worksheet. 8 questions, and the answers are at the back of the worksheet. Okay, so that's what I'd like you to do. If you've got any questions, please put them in the group chat, or I can pick them up next week. Thanks now, goodbye.